We know why global sea level rises, due to the way warming affects ocean water and ice. First, ocean water, like most fluids, expands when it's heated. Second, mountain glaciers melt when warmed. Third, the large ice sheets in Greenland and Antarctica melt and disintegrate into the ocean when warmed, either from warming from above, from the atmosphere, or warming from a warmer ocean below. Currently, these three sources, expansion of seawater, melting glaciers, and disintegrating ice sheets, contribute about equally to sea level rise. In the future, we expect the ice sheet contribution to become the largest factor, and that's a great concern because just the vulnerable parts of Antarctica and the Greenland ice sheet contain about 40 feet worth of sea level rise. But we are certain that additional sea level rise is baked into the system regardless of future greenhouse gas emissions because of various lags in the system. I'll close by reminding everyone that our history of defending infrastructure and people against coastal flooding is not particularly encouraging. We're always playing catch-up, fighting the last flood. In the meantime, sea level rise and flood heights are only going to increase in the future for the foreseeable future. This is a battle we are currently losing.
As Michael mentioned earlier, one of our largest uncertainties is how these large polar ice sheets in Greenland and Antarctica are going to respond when we're thinking about projecting changes in sea level in the future. So to answer that question, one thing we can do is look into the past because to some extent the Earth has done some of these experiments for us. It has been warmer before, those polar ice sheets have retreated, and so we can look to those examples to see how much they retreated under warming and how quickly that happened. When we're modeling into the future, one of the challenges we have is we've never been around to observe that particular process before, and so we don't have a full understanding of the physics involved in that ice sheet retreat. And that's why we need to go into the past to put some constraints on that. So in the last ice age, we had large ice sheets advance over, for example, North America. Sea levels dropped because a lot of that water was tied up in the ice sheets. And before that, there was another warm period we call the last interglacial. And the best estimates we have right now of what the global average sea level was during this time period is about 6 to 9 meters higher. So that's about 20 to 30 feet higher than today. The reason that finding is really important is that the global average temperature at its warmest during that time period was about the same as the global average temperature today, although the poles were a few degrees warmer, but those are temperatures that we are destined to reach in the poles in a matter of a couple of decades. So, okay, that happened during that one time period, but was that a fluke or is that a repeated experiment? So we've looked at several past warm periods over the last 3 million years, and we saw repeatedly that sea levels rose by at least 20 feet with anywhere from 1 to 3 degrees Celsius of warming, where each degree Celsius is about 1.8 degrees Fahrenheit. So that's a 1.8 to about 5.5 degrees Fahrenheit. So that's a repeated experiment that we see over and over again. Now, the good news about this is that that type of sea level rise is not going to happen overnight. We're not going to wake up tomorrow to dramatic flooding, right? As mentioned before, it takes some time for that ice to heat up and to respond to that. So I often talk to people about kind of like throwing an ice cube into a warm room and watching it melt. And you can think of these polar ice sheets as if we've thrown them into a warm room, and now we're sitting back and watching what's happened and how quickly they're going to melt. That is one of the remaining big questions to answer, though. How quickly will this process unfold? And that is a very active area of research.
You shouldn't think also of an ice sheet as just being just like snow falling and nothing, making this big, massive snowball and nothing happening. Basically, an ice sheet actually is a very dynamic system. It flows, just like if you were making a pancake, and you're making a pancake on a pan. You know, you put the dough in the middle, it's going to spread slowly towards the edge of your pan, making a nice circular pancake. Well, ice sheets behave that way. They're just, you know, you model them as a fluid that flows very slowly. So basically, ice sheets grow because of snowfall. They spread towards the coast and towards the ocean. They will lose mass by iceberg calving or by melting underneath the ice shelf. or on top of the ice sheet. And so a lot of our knowledge of ice sheets is basically behavior is linked to the observations that the satellites have made, or the observation that we've made on the field just by people walking on the field digging snow pit. As new processes are being implemented, we basically include those into our model. So finally, one of the factors about why it's so hard to make projections of future sea level rise is because us humans have an impact on future climate, and we're going to impact what the choices we make every day are impacting how much the oceans and the atmosphere is going to warm, and that's something that, as myself as a modeler, I have to try to incorporate into our models.
Sea level rise very much amplifies the effects of coastal flooding, and that's really how we're experiencing sea level rise most today and will in the coming few decades, making coastal floods more frequent, higher, more destructive. So colleagues and I are currently working on research that indicates that a significant fraction of the damages from Superstorm Sandy can be linked to human-caused sea level rise, those last few inches. And looking retrospectively, we counted up the number of coastal floods at 27 tide gauges around the United States since 1950 as they occurred. And then we subtracted out human-caused sea level rise to see how many would have occurred without that effect. And in fact, it's 2/3 of floods at those 27 tide gauges would not have been classified as floods without human-caused sea level rise in our analysis.